Hello and welcome to the section 2.2 lecture. Today we're going to be looking at dividing integers. So last time we looked at multiplying just integers together, and this time we're going to kind of look at the opposite of that, which is dividing integers. So let's go ahead and take a look at what they have for us. Just to get started here, we have this explore activity that talks about a diver that wants to descend to a depth of 100 feet. And she wants to do that in 5 equal descents. So she wants to go, a certain amount down 5 different times. I should say a set amount down 5 different times. And this is pretty common in diving because you do have to regulate your body with the pressure changes. So it's pretty common. It says to use the number line at the right to find out how far the diver will travel in 5 equal descents. So starting at the surface, we want to get to 100 feet below sea level. So how are we going to do that in 5 equal descents? Maybe this will help. So it shouldn't shock you too much to know that each descent, each time that we go down, is going to be 20. Now, whether you have to look at that like, well, if I go down 10 every time, I'll end up at 50. That's one way to look at it. So there's 5 times that I went down there. So then if I go down 20 every time, 20, 40, 60, 80, 100, that's 1, 2, 3, 4, 5 equal descents. So the way we went about this is to say that, really, she descends 20 feet each time. Okay, to solve this problem, setting up a division problem, to answer this, to get this 20, it would be negative 100, because she wants to go downward, so negative 100 divided by 5 times. Okay, we also could write this as a multiplication problem to say that our 5 descents times some number equals negative 100. So then we think about the sign rules that we have. Okay, so sign rules for multiplication: if the product is negative, one of the factors must be negative. And the key there is that only one. This really should say only one of the factors. And factors being 2 things being multiplied together, or each of the things being multiplied together. Since blank is a positive, since 5 is positive, the unknown factor must be negative. And since we know that 5 times 20 is 100, is positive 100, using the sign rules for multiplication, we know that 5 times negative 20 would be negative 100. And the diver should descend 20 feet in each descent. And then we want to use the process to so basically what we're looking at there is, the diver descends 20 feet each time. That's kind of what we said at the start. And if we were to kind of answer this problem, negative 100 divided by 5 should be negative 20. Okay, and we're using that negative to say that she's going downwards each time. Okay. So then these are just some practice problems, right? So we just want to think about it in terms of multiplication. That's what they're wanting us to say. And when we think about it in terms of multiplication, like this from step B to C here, our question is negative 100 divided by 5, okay, equals negative 20 for us. And so we want to rethink that as the denominator times the answer to that division problem is going to give us the numerator. Okay, so some vocabulary on fractions there that we may need to remember. Numerator is the top number, denominator is the bottom number. Okay, so if I'm thinking about this in terms of multiplication, I want to think what times the denominator will give me the numerator. Okay, let me even write that. What times, I'm going to say what number, so that just sounds a little bit better. What number times the denominator will equals the numerator. So what number times the denominator will equal the numerator? So what times -7 will give me +14? And maybe a trick that you might run on these is to first think about it all in positive sense. Like think of, okay, what times 7 will give me 14? Well, hopefully we come up with 2. And then deal with your negatives and positives. That's kind of the beauty of multiplication and division, is that we can kind of hold off on the positives and negatives until the end. Okay. So -7, it should be times -2. Okay, to give me +14. -36 divided by -9, we would think about -9 times what number will give me -36. I know that 9 times 4 equals 36, and since I want my answer to be a negative, this numerator up here to be negative, my 4 has to be positive. Okay. -55 times 11, or divided by 11. So 11 times what number will give me -55? Since I have a -55 there, my answer should be negative. Okay, and 11 times 5 would be 55, so 11 times -5 is going to give me -55. Okay, and then, okay, sorry. -45 divided by -5. Well, I know that 5 times 9 would be 45, and so -5 times 9 would be -45. So this 9 should be positive. And they ask a couple questions down here, and this may come up, I don't know, but what do you notice about each one of these problems? Note that they do have negatives. How many negatives are in each problem? And that's a big time key here. And I'm going to write it kind of as an important piece. I'm going to say if there are negatives, then there are exactly 2 negatives. Each one of those problems there has 2 negatives. I have a negative here and here. I have a -36 and -9, -55 and -5, -45 and -5. So if a problem has any negatives on it, and this goes for multiplication and division, if it has any negatives, it has 2. There can never be a multiplication or division problem when I'm talking about the problem, whether it's multiplication or division, and the answer. That's the big thing, is it deals with the problem and the answer, the question and the answer in this case. So if it has 1 negative, it has 2. Okay? And that can kind of help you out. Like this one, I noticed right away in my question here, 14 divided by -7, there's only 1 negative here. So I need another one. Okay, so let's try to read through what I wrote and answer this question. Make a conjecture about the quotient of 2 integers with different signs. make a conjecture about the quotient of two integers with the same signs. So we're talking about this is a total sign, what is the sign of our answer kind of thing. So this kind of comes up, what we wrote here kind of comes up here. So if I have different signs, and I'm thinking about quotients, if we have different signs, then the answer, I'll say the quotient, which is the answer to a division problem, is negative. So that would be like this one. There's different signs, 14 and -7, or this one, -55 and +11. So my quotient would be negative, which it was in both of those. If they have the same sign, then the quotient will be positive. So that would be a case like the other two. -36 divided by -9 is +4. The only other thing that wasn't really covered here is what if we divide two positives, right? That's something that we kind of expect you to know by now, is division of just positive numbers. So like if this was +45 divided by +5, we would get +9. And that's not to say that there's anything wrong with the statement that I wrote here, because I'm saying if there are any negatives whatsoever. If there are no negatives, then I'm not saying anything about that, right? If 14 and 7 were both positive, my statement here doesn't apply. This says if there are negatives. Well, there weren't any, so what do I know? All right, let's go ahead and look at an example that they have for dividing integers. It says that before we use the relationship between multiplication and division to make conjectures about the signs. You can use multiplication to understand why division by 0 is not possible. Now this may be something that we talked about before, may not. I don't know what happens at the earlier grades. So one thing that we are not allowed to do is divide by 0. And this is one idea of it. This is one thing that kind of helps. Let me kind of rewrite this how we saw it. We saw 5 divided by 0 equals something. And so what we want to think about in that previous page where we were looking at those different problems, we want to look at 0 times this something equals 5. Well, I can't multiply 0 by anything to give us 5, because 0 times anything is always 0. Okay, so the multiplication sentence says that there is some number times 0 that equals 5, and we know that that can't be the case. Okay, so we call division by 0 as undefined. All right, if you try it like in a calculator, it'll say divide by 0 error. It's that big of an issue that we even wrote the code in calculators to say can't divide by 0. All right, so divide 24, let's go 24 divided by -3. Okay, it says that we first want to determine the sign of the quotient. Since there's one negative, I know that my answer has to be negative, or we look at the fact that they're different signs. Okay, they have opposite signs, so I know my answer is going to be negative. And then there's no trick about this. I guess there is a trick. We went over a trick, but at some point we just need to know that 24 divided by 3 is 8. So 24 divided by -3 is -8. If you have to think in the multiplication sense, which I'll probably say that I do more than knowing my division facts, I probably know my multiplication facts better. And so I kind of use that opposite there, and I think 3 times what is going to give me 24? -6 divided by -2. Since those are both the same sign, I know that my quotient is going to be positive. And 6 divided by 2 is 3. 0 divided by -9. So the question here is, this is how we can use that multiplication idea when we have 0 on the top, because automatically once I say that previous thing that we can't divide by 0, I get people saying, well, this is undefined. You can't do 0 in a division problem. Well, you can, depends on where it is. 0 divided by 9 equals what? So 9 times what gives me 0? There's only one option. 9 times 0 has to give me 0. So when 0's in the numerator, or the first number when it's kind of written out that way, when 0's in the numerator, we get 0. Okay, let's look at a couple examples here. First off, 0 divided by anything is going to give me 0. And this one's a little bit trickier. Might not be in your common division facts, but hopefully you could figure it out. 38 divided by negative 19. First of all, what's the sign? Since they have different signs, the quotient will be a negative. And knowing that we're dealing with integers here, and we should get integers as our answers, we shouldn't get decimals as answers yet. I'm thinking our only bet is 2. And yeah, negative 19 times negative 2 is going to give me positive 38. Dividing by negative 1, negative 13 divided by negative 1. That's going to be 13, because negative 1 times 13 will give me negative 13. Okay. So using integer division to solve problems, let's go ahead and look at this. You can use integer division to solve real-world problems. Okay, we just want to make sure we know what the sign should be. So we've got Jake answers questions in 2 different online Olympic trivia quizzes. Okay. In each quiz, he loses points when he gives an incorrect answer. The table shows the points lost for each wrong answer in each quiz, and Jake's total points lost. Okay. So he's looking at the Winter Olympics and the Summer Olympics. Points lost for each wrong answer. Wow, in the Winter Olympics, he only loses 3. In the Summer Olympics, he loses 7 for each wrong answer. And then the total points lost. So his total points lost for the Winter Olympics was 33. He lost 33 points. And in the Summer Olympics quiz, he lost 56 points. So find the number of incorrect answers for the winter quiz. We're looking at negative 33 divided by negative 3. And that's going to tell us that he got 11 questions wrong. Okay. For the summer, we have negative 56 divided by negative 7. So he got 8 questions wrong. And then it says, in which quiz did he have more wrong answers? Kind of looking at which one did he do better on. So he got more wrong answers in the winter quiz. Okay. Let's go ahead and look at how we're going to use that. It says a penalty in Meteor Mania is negative 5 seconds. A penalty in Cosmic Calamity is negative 7 seconds. Yolanda had penalties totaling negative 25 seconds in a game of Meteor Mania and negative 35 seconds in a game of Cosmic Calamity. Okay, let's try to decode everything that's happening here. But it wants to know in which game did Yolanda receive more penalties, and we want to justify that answer. Okay, so let's first deal with Meteor Mania. So she had a total of negative 25 seconds in penalties. And we want to divide that by, for each penalty she would lose negative 5 seconds, or she would lose 5 seconds. So what do we get when we divide that? 5 times, okay, negative 5 times what gives me negative 25? That would be 5. Making 5 penalties. For Cosmic Calamity, she had a total of negative 35 seconds lost. and she loses 7 seconds per penalty. So negative 35 divided by negative 7. So think of it in multiplication. I think that is the easier track. Negative 7 times what gives me negative 35? That's also going to be 5 penalties. So she did kind of the same. She had the same number. Of penalties. In each game. Okay. All right, so that'll be it for today. The last thing I do want to go with is I do want to get us a code word because we started talking about division, and we dealt a little bit with some key words. I'm going to go with numerator. Okay, and numerator again is the top number in a fraction. Okay, and where numerators come into play a lot in division, it's the first number in the division. It's the first. Dividend, I would say, is the same as numerator. They mean the same thing. They don't mean the same thing, but they are closely related, I'll say. All right. So get those notes done. Get the all the work done, the reflection questions, and we will see you in class. Have a good day.